Right, let's get going with the third episode of this plugin voids we are making in Rhino live coding. Let's see where are we at. So we now have, let's put it like this. So we now have our command in such a way that we have set up the options. We create a point, handle the get loop, and at the end add an object if that's what we want. Right, I guess we should have a little chat about what I plan to do with the plugin or with this first command. So let me fire up Rhino and have a quick look. And let's see if I can draw on my screen as well. So we're going to explore a little bit about the things I plan to do, and a little bit on how I currently see it, the structure of this first command. Let's see, let me pull up my Control Alt and G. Did that work? Not necessarily. Let's see, let's do this again, just like this. All right, now I should be able to draw something. So the idea is that we, with the command, add a box with a width, length, and a height, and at a certain location in this part. And while the command is running, the user can change these settings and pick a location. And that is something that essentially already works, but while the command is running, it would be nice that the user could see what it is that is going to be added. So we're going to work on a display conduit, and a display conduit allows us to essentially work on that, as in allow sorry, I have to handle a few things here. Right. So the display conduit allows us to essentially draw in the viewport, without adding geometry to the document. So that's the most important part here. Hello Lucas, thanks for joining. sorry, I lost a little bit my train of thought there. So DisplayConduit is what we are going to add or get started with adding now, so that we can draw in our viewport without adding data. So normally user adds data, and of course that gets just normally drawn. But our DisplayConduit, let me get my pen up again. The DisplayConduit allows us to draw geometry that we don't have yet added to the document, and in that way we can do essentially a sort of dynamic preview of the input that we have received from the user. So let's go back to the code as we have it right now, and I don't think there is much to change here. So right now the command is called, let's see, the command is called yesterlive code command 1. That's not really a useful name, so I was thinking of renaming it now to something a little bit more useful. And so the idea is that in this journey to of creating a plugin, the object that we are going to add. So let's pull up the pen again. So the object we're going to add, let's say this object here, that with this object there would be a panel, something that would go in here. I have quite many at the moment, but one of these would become a panel, and then that panel would have a UI. Maybe let's change to, for a moment, to let's say the notes, so I have some space to draw in. So we're going to have a UI, and then at least have entries for weight, height and length. I don't know yet what exactly. Input boxes, or maybe probably better a slider. Let me remove those. So I guess something like this. Although a slider may be not necessarily what we want, but at the moment our command has been set up such that there is a range for each value, in which case a slider may make sense. And maybe we can even use the open-ended slider that is available to us. So in that case, the slider would essentially look a bit like this. Oh, that's open-ended. So you could drag the slider past the limit, and you'd get a possibility of having bigger numbers than what the initial high maximum value would be. So the maximum, minimum, or at least the maximum would be a soft limit essentially. Hello Gintars, thanks for joining. So on that object that at the moment is just going to be directly the brep, but in future streams I would like to make this object a custom object. So this would be, let's say, an arrow like so. So that would be a custom object, as in we create our own Rhino object, which would have its data, like these settings and the location. So in Rhino, especially when you are going to look at the data, we have our document, this entire thing here, which has data in, like layers, document settings, but also the geometry. The geometry is in the document table or in the objects table of the document. So with Python script context, if you have that imported, and then the currently active document, it will be the objects table. That is where we are going to put our objects in, and each instance of these would be Rhino objects. So this is a Rhino object, and Rhino objects have attached to them, let's draw a database essentially, it's the attributes, and they have like name, many different things. What we are going to do is have our own object that also has attributes, and put all the necessary information in that data, so that we can recreate this object when the file is being read in again. So that's the plan at the moment. I suppose we'll see in the future how well we stick to this plan. So let's get rid of this Rhino instance for now. And okay, so I just explained I want to have this command generate essentially a custom object that can be manipulated with this separate panel, a little bit like a parametric box. So I'm going to rename this this command to yester box, I guess. So our command class is going to be called yesterbox, which will generate okay, it helps being able to spell, which will generate a custom object. And let's put in here just to be done. That can be eventually controlled via a custom panel. Right, so let's call this one yesterbox. So there's the file and the namespace that can be still yesterlive code, but yesterbox. Maybe call it yesterbox command actually, because as in the class is going to be yesterbox command, because at some point we want to add our custom object, and makes sense to call it then yesterbox command. Right, like so, and then still change the name yester. Now it can be just yesterbox. We are going to add yesterbox. Maybe, yeah, right. So we have box in Rhino, and now the new command is going to be yesterbox. Let's quickly generate the code. So now I have yesterbox command, and we have still the old one. I have to clean that a bit up. But just yesterbox command now is the command that we are going to build on or continue to use. Let me quickly add or change it here. So this is going to be yesterbox command. For those who haven't been in the first stream, at the moment I'm going to do handling the project file manually. I actually realized that I could do this also in the literate way. Then it would be maybe even easier to maintain that. Right, so yesterbox command, and let's also do a quick rename. Let me for now, for this moment. So let's go to yester live code, and we have the yesterbox command file, and let's for now remove it because it's just generated from the literate code. And then we are going to do git move yester live code command 1, tab completion of course, to yesterbox command. Right, and now if I am going to regenerate the code, now we have just one file with the new changes in. So git status gives us the renamed file and the modifications. Yes. Right. So DisplayConduit. Let's get started with that for now. So we need a new file for the code to live in. We could do it of course in the same command file, but let's put it just in a separate file, just to keep it all organized. By the way, for those who are watching now, if you have questions about anything regarding writing plugins for Rhino or the way I work, just feel free to ask questions in the chat. Creating a DisplayConduit. So to be able to show let's call it intermediate results of our command, or while it is still running, we can use a DisplayConduit. This will allow us to draw results without having to actually add geometry to the document. So I have done DisplayConduits before. It's been quite a while, so I thought it would be a nice moment also to show a bit where one can find information about different parts of Rhino, especially when you're working on developing a plugin or a script or anything like that. Developer.rhino3d.com is the central hub of all the documentation for developers. We have a section with guides, a section with the API documentation or links to APIs, and and links to samples, some videos, and then finally to our forum. For C#, we are mostly interested in just Rhino common. So here are some guides on Rhino common usage, mainly C#, but any .NET language should work, and at least for Rhino 7, of course, the Python integration that we have, which is on IronPython, or with IronPython you can do many things also using Python and the Rhino common API, which is what I prefer over the Rhino script syntax module actually. But lots of articles on the different parts of Rhino, and one of them is DisplayConduits. So it starts. This article starts by laying out how this DisplayConduit can tag into the display pipeline. That is the main way of visualizing things in Rhino, of what Rhino itself uses to draw anything on screen in the viewports. So there are several steps of that. Init frame buffer, set up frustum, calculate bounding box, pre-draw, draw objects, and post-draw. And for the different phases of the display pipeline, there are events that are getting called in your display pipeline implementation, and in that way you can set up essentially your own class for drawing your geometry. For us in this stream, we are going to be looking at calculating of the bounding box, and we are going to draw in overlay, and there's actually also a small implementation example for that, and this is something that we are going to build up on, and I'll touch on these bits when we get to them. So let's first get started with adding this new file. So a new fragment, C#, master box DisplayConduit with a dot asterisk in that tells my literate extension that this is going to be a new file, and I can give a file name that is going to be yester live code and then yester box conduit. Right. We are going to need some usings, so this is going to be our master box usings. We are going to put them here, and then we're going to have a namespace. So it's still the yester live code namespace. It's going to stay the same, and in here we have our public class yester box conduit. We are deriving from, and when we look at the documentation, we are deriving from rhino.display.displayConduit. So Rhino DisplayConduit. To implement the DisplayConduit, And let's also, so that's going, let's add some markup here, or markdown I should say. So this is DisplayConduit, class name, and same over here. And I spelled this wrongly, so let's fix that as well. Conduit. We need to inherit from Rhino DisplayConduit. Well, let's not use the word from. So we need to inherit this class and at least implement calculation of bounding box. So that's actually scene bounding box. Let's say it like that. And a draw method for our command and DisplayConduit. We are going to draw in draw overlay. Like so. Let's have that nicely distributed, the text. Yeah, right. Going to go back to the documentation again. So what I like to do also is just refresh my memory. And in this case, I want to have a quick look at the documentation. I have to say, although we have a lot of documentation, there's still places there that are a bit lacking. A good description here would have been nice, but fortunately we have the article over here on developer.rhino3d.com. So if Rhino is in a feedback mode, the draw overlay call allows for temporary geometry to be drawn on top of everything in the scene. So yes, at the moment, at least I'm not going to worry yet about depth buffers and things like that, drawing before or behind objects, if it really should be before or behind an object. For now we are going to just look at the draw overlay. And we can improve this later on. We must not forget to add the proper namespace. So we can use it in our class implementation. So that is going to be a new fragment, C#, and the fragment is called yesterbox usings. And that is going to be using Rhino display conduit. And actually, because I'm now importing the let's not import that one, so just the namespace. And since the namespace is now here, I'm going to simplify this here. Right, let's put instead a couple of curly braces so that this is correct. Calculate. Bounding box is what we need. Bounding box. I'm going to add here also the name yesterbox conduit calculate bounding box, because mainly because my literate plugin looks at the workspace folder, And if I have several .literate files, each with a fragment called calculate bounding box, that's going to cause problems. At the moment, throughout the entire workspace folder, fragment names for new fragments should be unique, something to be improved later. So for implementation, as I said, we need to calculate the scene bounding box, and we need to have a gesture box conduit draw overlay. So let's start a new chapter for that, and calculating the bounding box, and another one for drawing the temporary data, of data. Let's do it first like that. We can always rename later. I like to do this, adding the section headers also, because then I can use the markdown document outline to quickly go to different locations in the document. At the moment this is going to be one big document, but I'm sure that at some point we're going to split this up into separate documents. So the documentation can be in as many documents or files as you want. For now we keep it in one. So calculating the bounding box. To calculate, how to tell the display conduit to display pipeline, or maybe I'm going to rephrase it. So to be able to properly draw our geometry, we need to tell the display pipeline what the bounding box is for our geometry. This is necessary. Oh, I was to be able. So I was going to say essentially the same as in the first sentence, so let's not do that. Without the proper bounding box, geometry will easily get clipped, and we don't want clipped geometry. I suppose as a test or as a demonstration, we could at some point do a version of this where I just disable calculating the bounding box, and we'll be able to see how this affects. So gesture box conduit, calculate bounding box. So calculating of bounding box, yes. Let's look quickly at the required signature. So it's protected, and we're going to override it, and it returns a void, but it has a calculate bounding box event args in it. So this is where we are going to do our changes. Let's quickly look at the example. So we have here protected override of the calculate bounding box function, and we are going to call include bounding box. So we are going to extend essentially the bounding box of the scene with our bounding box. So if our bounding box is already contained within the scene, nothing really will happen, but if our bounding box is outside of what we have physically in the scene, so we have just one tiny box, and our box we are going to put outside of its bounding box essentially, then this would get clipped, this geometry of ours. So that's what we don't want. So protect it, override void, calculate bounding box, and that would be calculate bounding box event arcs, right? I could have copy pasted it. Calculate bounding box event arcs. Maybe let's put in the correct parentheses or braces, curly braces. So in this case it's good to essentially actually call the base first, so we don't know if there's any special stuff going on. So just make sure that we're calculate bounding box. We're just passing on the reference of this bounding box event arcs, and then we are going to add our own data. But at the moment we have no way of doing that yet, so we need to actually adapt our class in such a way that we can pass on the data. Before we do that, let's temporary geometry, add just an empty, or really simple, so essentially empty placeholder function for our drawing. That's going to be the raster box conduit draw overlay. And that's going to be, let's peek again. Oh, this is pre-draw objects. So let's look at draw overlay, signature, protect it as well. And we get the draw event arcs. Protect it, void, override, void, draw overlay, and that would be draw event arcs, draw event. And at the moment we are not going to do anything other than make sure that our base is called. And we are going to have a think about how to ensure that our data that we want to visualize is going to be given to our conduit. Now that we have our conduit here, we can kind of start adding it. Ctrl-Shift-P and generate our code, so no errors there yet. So we have our creating our command. Let's clean that up a bit. So I'm just quickly looking for where I mention DisplayConduit. I don't mention it here yet, so let's do that in the top. So while our command is active, we'll be drawing temporary results with the display conduit called box display conduit. Since that lives in our own namespace, we don't have to do any importing of that namespace. Let's see, first command overrides. We are going to do this inside the run command implementation. So how we're going to do this is we're going to have an instance of our display conduit initialized at the start of the command, and then update the data for that display conduit based on the information we get from the user interaction. We're going to update data into the display conduit instance and then have it draw. So at the begin we do add command options. We create our get point command or the instance for that, and then we get into the loop. So we have to do this before the loop. So let's here we have set up the command options and the get class, the get point class. So we set up display box display conduit. And I think we are going to the mandatory overrides for command class. Maybe add here a new section. 1, 2, 3, 4. That was going to be our run command section. Run command implementation. So now I can quickly here see it in the outline. So we add the command options here. Then we do our point setting, get point instance with the options that we have created earlier. Then here, before the handle loop, we are going to actually add this display conduit. I'm thinking, I think, let's see if we can have a 5th level. So this is going to be here for 5, and then call it command options, and then we are going to do a section called get point instance. And now we can do our loop handling, input loop handling. So based on the how the Rhino commands work, each time you do something, you get out of the so you get point.get. We are now waiting for input from the user. Something happens, we react on that, and we continue that in a loop until we are happy with the information we've received from the user, or we abort if the user wants to has pressed cancel. So that's why I call it input loop handling. So now we are going to add initialize the yester box display, or maybe just call it initialize the display conduit. To visualize our the user input, we need our yester box display conduit. We need to give it all the information. It needs to draw properly, and with this we now also will find out what we actually really need to add to our class. Let me come on, grow this a bit. First, however, we need to initialize an instance that we can use. So display conduits work in such a way that you create one and then you tell it to be enabled or to be disabled, and this is actually quite global. So either your conduit is enabled and it will draw in all viewports, unless you add to the specific drawing implementation, so drawing function implementations code that checks what the current active viewport is. Then you can decide to skip or not skip. Sorry. So let's back up there a little bit. Quickly start Rhino and get my screen drawing part active. So adding a display conduit, you add and you enable it. It's enabled for each viewport there is in your Rhino application. So in this case there's 4 of these, but you see there's only one active at the moment, or at any time is one active. But even so, if you just enable your display conduit, it will draw in all viewports, unless you tell, so it will go in this way, that your display conduit will be called for this viewport, and then it will be called for this viewport. I don't know what order, but any order, this viewport and then this viewport, and then you can check whether the viewport that's currently being drawn, if it's the same as the active viewport. So if you want to draw only in the active viewport, you can do it this way, by making sure that that your viewport that's being drawn is also the active one. So with that out of the way, let's close this one again. We are going to add our wrong key. What am I doing? Let's see. I pressed something, not entirely sure. So initialize the display. I probably forgot to go into input mode. So C# colon, and then yester. Oh, what did I say this is going to do? So it was set up yester box display conduit. Set up yester box display conduit. Right. Oh, set up yester box display conduit. I used just normal words here instead of the class name. It's fine. This is where code completion for the literate plugin would be really nice. But we work now with this. So we are going to have yesterbox display conduit equals. It's going to be a new instance of our like so, and that's essentially it. I'm going to also just enable it. Conduit enabled equals true. Oh, not Python but C#. So like this. Let's check our. Oh, not that. Let's check our code documentation, our API code documentation, if it was exactly enabled. Into the properties, enabled, yes. So you set whether it's enabled or not. So it's going to be like that, and we want to add set here our information. So what we are going to do now, so I'm just going to do it like this. So it's going to be location equals, and it's going to be point, and it's currently unset, so we have to check that soon. And then conduit width, and same for height. And length. Right, but these don't exist yet, so we have to make sure that they are actually added. Width, length, height, yes. Good. So what we are going to do now is we are going to add those to our class. We are going to call that just yesterbox conduit. Oh, so I called it yesterbox conduit, not DisplayConduit. I have to fix that. We would have soon enough figured that out when compiling. And again, also here, of course, code completion will be really nice. But we are going to work like this for now. Yesterbox conduit data access. So to implement, we need to inherit this and at least implement. We also want to be able to pass on the data to be visualized, which we'll do with yesterbox conduit data access. So let's put in a ticks here. And wrap our text properly. So let's have a extra section here. Data access, maybe only 2 C's. The display conduit implementation. right, will provide several properties to set and read the information we want to visualize. This will be for the location, width, height and length of our object. Rewrap like this, and then C# yesterbox conduit data access, new fragment, and that is going to be 4 properties. So first our point 3D location, we are going to just really simple get set. We don't need much logic here. What did we use actually for our, so for our width, length and height we used integers, so let's continue with that. I know it's a bit limiting, but we can always change it in the future. Width, height, get and set, and for the length, get and set. And since we need point 3D, we also need to since we need point 3D space, we also need to bring in the Rhino geometry namespace. Namespace, and that we can do by extending the one we already have. C# yesterbox usings equals plus, oh that's minus, plus using Rhino geometry, right? I now wonder if this is what we used at the beginning. So initialize the display location, width, height, length. Yes, we did that. So now we should be able to actually almost compile this. I just need to make sure that our yesterbox display conduit cases are called yesterbox conduit. Actually, I think I'm going to rename the conduit. Well, yes, this will be fine. So percentage %s, so substitute in the entire document yesterbox display conduit with yesterbox conduit globally. Ta-da. So let's realize our code. This looks fine. This looks fine. And yesterbox conduit. Yes, of course I need to add yesterbox conduit still to our project file conduit. Otherwise our what's it called? Otherwise the code completion can't see the file. And here, of course, I noticed that this is still being private because I did not specify that in the code here. So let's do that now. So creating a display conduit, data access. These are of course not private. We have to explicitly tell them to be public. I suppose we could do internal as well, but it's not that interesting to hide that. If someone else wants to use this conduit, why not? So now look at this, is now all fine. No red names here either. So maybe it's time to do some building. So .NET build, right? And that built just fine. Okay, at the moment actually we are not drawing anything yet, so let's now continue with the calculate bounding box and with drawing of the actual stuff. So first our bounding box. I suppose we are going to, what are we going to do? I don't want to do this too many times. So our bounding box, I suppose if we peek a bit at the documentation, there is a bounding box class already here for us to use. Let's just search in here, bounding box. Oh, it's a structure and not a class, yes, of course. So I was looking at almost the same, or I was in the right location, just not thinking hard enough. So I think what we're going to do is use the code or extract the code that we used to add the box. So this part, so we have a plane and we create the box. I think we are going to use this part and have that in a function, so we don't have to do this multiple times. I shall put it somewhere useful. But where is that going to be? So I could add it as a function on a static function on, say, this command. Then I could use that static function in the display conduit. Since it's static, it won't depend on any data necessarily, so I suppose that should be just fine. I'm just wondering if I want to optimize things already, but maybe let's not optimize at all at the moment, so we don't get into awkward situations later on. So I'm just going to extract this into a separate static command. So, right. Let's see, so we have our first command overrides, and we are going to have here how shall I call it? Cluster box command utilities. So let's also mention that. So apart from the command overrides, that are, apart from the necessary command overrides, there will be some utilities implemented in this class that can be used for creating and visualizing our object. Right. These will be provided in, and then put our tag yesterbox command, or with a let's fix it in the other tag, yesterbox command utilities. And let's rewrap our text a bit. I'll fix quickly here our writing of this tag. Right. So around here, where we are going to add our object. So let's go down. So we should add actually here at the end a section called with 5 asterisks, or non asterisks with 5 pound signs, 1, 2, 3, 4, 5, adding the object. To add the object, we use the create box, yesterbox. So I'm going to add a function called yesterbox, create yester. To add the object, we use the create yesterbox method provided by, and this is going to be the yesterbox command utilities. So here's the good moment to add the first implementation. So let's add the new tag, fragment yesterbox command utilities. So this is the very first one, just the equal sign, and later on if we find that we need to add more stuff, we can extend it with the equals plus. So this is going to be something that gives back our brep. Actually we could also do a extrusion. Let's see what we are going to do. I might change it to an extrusion later on. But, public, so it's a static public function that gives us a brep. Create yesterbox. So at some point it's not going to be the brep, but just the actual new geometry that we want, I suppose. But if we take a point, 3D point, and int width, int height, int length, and now we can copy paste this implementation here, or cut and paste is actually what I'm doing. So, and then return box brep. and this is going to be brep box brep equals create yester box with the point, with height and length. So now we have something that we can also reuse in our DisplayConduit. So in here we are going to do brep box equals and then we are going to use what did we call it, yester box command dot create yester box with the point, width, height and length. And from the box we can get our bounding box, which is obviously I don't know that by heart, so let's see. We should have a way to get our bounding box from geometry. Get bounding box. If accurate is true, a physically accurate bounding box will be computed. If not, a bounding box estimated will be computed. And estimated bounding boxes can be computed much faster. So I think at the moment we are not interested in super accurate, we just want an estimate. If it turns out that we do want accurate, we can always change. Oh, now I did look at it, so it was get bounding box. So we are going to have bounding box bb and then have box get bounding box false. We are interested in speed now, and now we can extend this one. So it was called include bounding box. Oh, I don't want to do that. I want to go here. So include bounding box bb. We can actually check still here if that's going to work. So on Rhino DisplayConduit, we had our calculate bounding box and our event arguments that had this include bounding box. And what does it take? It takes the bounding box. Right, and now the drawing we can essentially do the same. We get our bounding our box, and then actually from this I'm going to get the render mesh, I think. Actually, let's check what do we have here to draw. So let's go back here and here, and let's look at our draw overlay. So we have event arcs, and that has a display, and this display is display pipeline that we're going to use to do the actual drawing. So let's see what kind of goodies we have here to draw stuff. Let's see, we have draw 3D text, 2D lines, rectangles, arcs, arrows, bitmaps, all boxes. We could have just gone with that. brep wires are shaded. Well, maybe we are going to be lazy and just do this. Let's see the other one. Brep color is a bit easier. So maybe we are just going to draw the wires, so have just the outlines essentially. Or not the outlines, but it says the wires. Depends on how the wires are set up. So on draw E we have display property, then we can do draw brep wires, and then we give the box, and then we still have to have a color. So system drawing color, what it, right? System drawing color, right? And then some color. I think we're going with blue for now. And let's see if this generates properly and builds properly. Let's build it now. Build. No. Right. Point is a type which is not valid in given context. So let's see. Oh. Oh, I called it location. Yes. Let's put in location then, not point. Okay, location, and this one as well. This is now fine. Let's build this again. Ah, much better. Let's see what we get. Let's start Rhino and try our yesterbox command. Yester. No, let me type properly. Yesterbox maybe. Oh no, it hasn't been loaded before, so I'm just going to load it now manually here. Plugins, not shipping with Rhino. There's this one. Here's the live code, load plugin. At least that loaded. Huh. I wonder why it's still saying. Oh no, right. For some reason it was still showing the old one. I guess it hadn't been reloaded yet. But now next time Rhino should know about yesterbox command, so when I start it, it should already know about this. I don't have to manually load the plugin anymore. So let's have a location and just, well, it should be drawing. It's not. So I'm sure I'm making a mistake somewhere. Is that where I last clicked? Yeah, this works fine. So I have to ponder a bit what I did. I did set it to true, as in active, enabled. Well, that should be it. Let's go back to our guide here. So we have a conduit enabled, and whenever anything is drawn, it gets hit essentially. So that should be it. That does remind me of the fact that we need to disable it at the end. So let's do that at the end. So creating the command, loop handling. So here we return. We're going to disable our conduit, which we called conduit. Conduit dot enabled is false. Actually, this is a good spot to also do some refactoring so that we don't just in the middle of this part go out, and that we don't have to remember to do disabling of the conduit in different places. But we can do that at a later state, I guess. And then here at the end we're going to disable it as well. We also disable our conduit so it doesn't get called all the time for nothing, because we want this only at the sorry, I'm just being distracted a bit with some happening in the chat. Where was I? So we also need to disable our conduit so it doesn't get called all the time for nothing. So let's do that. We can do that before we are adding. So enabled is false. Create gesture box. Let's see our drawing stuff again. So we have calculate bounding box. We extended, and we have this code running. Yes, that's obviously not very useful. Let me see, what should I do here? I suppose one thing is to start actually a debug process. Start debugging, and we don't have anything done yet, so let's not do this one. So go run start debugging, and I think we are going to do just 4.x at the moment. What is happening here? Okay, I'm just going to do this manually like this. Add a configuration for running. What are we going to do? Well, it's not .core actually, .NET Core, but let's see. Let's do a local .NET Core app. So this is going to be, I have to peek a little bit how I do this in my other project, so just a moment please. I'm going to look at, so what I'm now trying to do is I'm going to set up this launch configuration such that Rhino gets started and then I can attach to that process. I have done this in another project, so I'm just going to quickly peek at it off screen. Let me see. Launch for Windows.net. Okay, I'm going to put in as a program. I'm going to put in my hard-coded folder. So that's going to be, I mean, the installation folder of Rhino. C program files. Rhino 7. Oh, Rhino 7. System Rhino.exe. Arguments, I don't want a splash screen, so no splash. And that's actually it, I guess. Do I want anything else? This is core CLR. Now I'm going to put in CLR. Oh man. So and this is going to be start Rhino for debugging. You want to launch. I'm going to command out the pre-launch task for now. Space folder is, I guess, okay. Work directory, but maybe I'm just going to use the Rhino system directory. That's what generally our shortcuts is pointing at as well. Well, let's see if this is going to work. So, so let's start Rhino for debugging. Click. Ooh, lots of stuff is happening. Now, while it's running, I'm going to put a breakpoint in the conduit. Oh, too late. Come on, conduit. And let's put it here and here. Let's actually see if it gets loaded properly. The plugin, I mean the breakpoints, by first manually loading the plugin. Let's see if we know plugins. Yes, they are loaded here, so we should get hits on our breakpoints. Maybe even put just a breakpoint here at the very beginning, like so. And then we start Mr. Box. And here we have our first breakpoint, so that should be fine. But let's now continue for now. So we get draw overlay at least. What do we get? Okay, so this is actually going to be a release build, so maybe it's not the best. Let's see. Not the most useful part that we have at the moment. We can't see stuff here, so I should make sure that what are we having here? Yes, the live code. So this is a debug version. Or maybe I could try .NET Core after all for the debugging, but we do get hit here, so that's what we wanted to know. So what is null? Is our box not proper? I guess so. So one change to this one. Let's try core CRL. If that works, better for us. VS debug. Let's see. So our breakpoints are not yet loaded. Now we load our plugin. Let's do this still manually. Load plugin. Now our breakpoints don't get loaded at all, so we need to use the CLR environment. VS debug. We're not using that at the moment. So CLR. I'm actually not sure what this VS debug means. Is that something I could use here? I don't know. No. It's not recognized. So for some reason our box is not really good. That's what I'm surmising here. Because we did get into this function. Maybe have a breakpoint here then as well. Let's try this again. So as said in the description, or at least when I announced the stream, that there will be mistakes. Well, we have now some mistakes, and we are going through the motions of figuring out why it does not work. Let's see if we get now proper breakpoints. Yes, it's now there at least, and everything is loaded. Let's see if our lots of stuff is being loaded, but we are interested only in our own plugin here. There's so much stuff here. Sketchpad, old project. So here, symbols are loaded. Well, let's try again then. Yesterbox. We get into this one. Actually, this breakpoint we don't need. It's not interesting. We still don't have variables here. I've been testing this with my other projects without problems, so I'm not sure why it's not showing here. This is not going to be a very useful way of debugging, so maybe I have to just jump into well, something did show briefly here, but not what we want. I think I'm going to jump into Visual Studio Code and just attach with that to a running process. I already was debugging a crash with Rhino cycles during compilation of not during a startup, where compilation of OpenCL kernels or the part that the code that does that, it trips over problems. So let's start with a without code, and I'm going to attach to. Oh, maybe I can load the project. Let's see. And let's hope that it's not going to. No, not this file. This window. I wanted this one. Where did I put the code? Or maybe I want to use the shortcut here. Reveal in File Explorer. Yes. I now have Visual Studio and load that. Oh, it's loaded. Debug is fine. Let's put breakpoint on. Not on that. I want on the create command. And then the create gesture box part. Now we're going to attach to process. To this one. And then load our plugin. Let's see if our breakpoints then properly get initialized. Oh, that's not the plugins part. Plugins do not ship. And I'll load this plugin. It's loaded now. Let's see if Visual Studio also sees that. Yes, it sees. So how do I do this in a good way? I guess we just start the command and let it hit there. Our locals, there are our locals. Oh, that's peculiar. There are no locals here. I did make an applied updates to Windows, but not to my other parts. So let's see if I have any settings changed here. General, step over properties and operators. That's what I disabled actually yesterday, but that was the only change. I must say I am a bit stumped on why the symbols do not show properly. So symbols are loaded. What is this? Symbol file is where it was generated, so that's as expected. Not sure why this is doing that. So maybe I'm going to let this run. We still don't have locals, right? I can't see any symbols at the moment, so I'm going to restart this and attach only with managed instead of managed and native. plugin already. Oh, so many plugins. Hard to see easy. Load the plugin. Okay. And now we go back to Visual Studio and attach again to Rhino. This time we make sure we have only managed 4.8. So I guess just one here. Now we still have the other one, right? Yeah. So something here is going wrong. And I don't know yet why or what. If debugging with the debugger doesn't work, we're going to do it old school style with writing stuff to the output window. So yesterday box. Let's step a bit forward. We still don't have our local, so it's going to be hard to understand what's going on. Our modules. User code, yes. Load it. So it tells, it was first looking in the system folder, that's fine, and now it found them there. It's loaded. Symbols are loaded. Let's load them always automatically for this one. If any of you in chat has an idea of why this is not showing up, do let me know. In the meantime, I'm just going to, or maybe you can do intermediate window. What is P? What? Local variable P dot I do have Rhino Nature installed, but I would be surprised if that's the cause. I've been debugging just fine with the Visual Studio. Just not this is the first time for this particular project. So there's probably something I'm missing. Would be nice to know if this is null or not. So I guess we're going to do the old school way. Don't save, we don't want a solution file. And this we don't want. So here we're going to do if box brep equals null. So if it's not anything useful, we are going to or maybe throw exception already here. Something is amiss. Throw new system.exception, I guess, and have that a proper semicolon. And maybe you can do also a system diagnostics debug. Not console. Wait. right line. We have an invalid brep. Or maybe add some. Oh, I wanted to add these. As a visual separator in the output we get. So we regenerated the code. Now let's rebuild this. And now let's just start. Actually, we can put in a breakpoint in the command part where we... what? Why? Did I forget to save before generating the code? Oh, yes, of course. Sorry, I'm being a bit dumb here. I was supposed to do this here. So if box brep equals null, oh, null, we are going to write something to the output window, so system diagnostics debug, right line, our prep is not good, confused emoji, and why not also throw... Actually, we don't need the exception, we just need this place for. We just need this place for being able to put the breakpoints, but we're going to actually add here. Wait. Right. Data we have is a location. Oh no, point. Width times height times length. So we want to print it out as well. And we had one more line, so we can actually put a breakpoint on that. So we've now regenerated the code. We can put a breakpoint here. We don't want here. You want to know when it is incorrect. And now start Rhino. So I'm actually not sure why this is not working, because or maybe I'm just passing in the wrong data. Who knows? Yesterday box. Oh, I probably started this the wrong way. Right, we need to start it just from here. Start Rhino. Right. So yesterday box. We do get hit here. So we don't want to get hit here anymore. We know that the draw part gets hit. So what did we get? Let's check our output. So wait. Our box VREP is 0. I mean null. So maybe our box is incorrect as well. I probably should have. Let's check the documentation still. Here. So we go to box, namespaces, geometry, and we had a box somewhere. Box. And from that we wanted a brep. So there was the 2 brep. One thing that comes to mind, what we could do is, instead of setting unset at the beginning, so maybe that's the problem, point maybe unset. So at the beginning of our command initialization, when we have our inputs here, instead of using unset, we are going to use origin. So let's see if we compile that. And then debug. If our VREP now is better. But I have to admit I don't fully understand why then adding it works fine. Oh wait, I don't need to open anything, I just need to start this. Okay, so it was exactly that. And now I clicked something, we get into bounding box. Let's see if our okay, so essentially it's kind of working. There's one step we forgot, and that is setting the data of the change data to our conduit. So let's do that still, and then we have a working conduit. I suppose I should have realized this before, that using unset is going to give problems. We don't need unset in this case. So in our handling loop, maybe explain a little bit. Each time an option is changed or a point is clicked, we need to update the conduit as well to ensure proper visualization of the current settings. So let's make that a bit nicer again. Oh, like so. And then point, we're going to do a conduit location equals point, and then over here we're going to do conduit dot width equals width and height. Oh, equals height and conduit length equals length. So one more compile. And then let's start from Visual Studio Code. And let's just run yester. Oh, what's happening here? Yester box. So now I have a box. Oh, and it is not updating. And why not? Let's put in a breakpoint. Oh wait, did I regenerate the code? Yes, I did. So oh wait, maybe I can. No, it should be drawing. So we have a point location here. Let's put in a breakpoint. Oh, not in here. Let's put the breakpoint in our command, right? Oh, right. Maybe actually regenerating this would be good. I probably should make a. Oh, this gets overwritten, so regenerate like this. Now it should be all just fine. And let's start this one more time. Always annoying when things don't go right as planned. I should have realized that point 3d.unset is going to cause problems. I actually was thinking about that the other day, but completely forgot about it by the time we're got to we have some breakpoint, I guess. Yeah, we don't want the breakpoints anymore. Thank you very much. So now our conduit is nicely updating, and if I make changes here, let's say 20, or height 5, length 7, and maybe relocate it and then accept. So now we have a command with which we can generate new stuff, I mean new geometry, and also visualize while our command is still active. So you can see our command is still active. Visualize what's going on. Unfortunately, a bit of time got lost in figuring out what I did wrong. I hope my lesson is learned this time. And for the next time we can just continue working with Visual Studio Code and using our brains. So, just because it was so nice looking, let's try one more time. Our conduit is updating each time we do something in the viewport, click, or we interact with the command. Let's say again width to 25, length to, I don't know, 30, and then more clicking in whichever viewport actually we want, and then we're done. So, question about if next time there will be a panel development. I suppose we could have a start at panel development. And there's two things that we still need to. So the panel is the one we need to do still, and I would like to have a custom object. But the road to the custom object, we may start by doing it in such a way that we maybe could use user data. So add strings or entries to the user dictionary that's on each object, and play with those. But yeah, why not at least have a simple panel that would show up here in the right hand side. A simple panel with maybe just a location that we could at least already encode with these user strings. I mean user dictionary data, the location with the height, and just show that. And then as the next step, add after the panel, first iteration of the panel, have the custom object, so that we can do the custom parameterization of the box in the future using that panel. So those are the things that we'll be looking at in the near future. So the panel indeed will be done in Etho. All my panels I have been doing for a long time, including the ones in Rhino cycles integration, have been done with Etho. So sure, we can look at how to set up bindings in Etho, so bindings of widgets with data stores in behind. And I have mostly done pretty simple stuff. The most complicated UI I have done is in this options part of cycles, and that's the device settings. So there's this tabbed panel and with grids in, and depending on what kind of devices you have, they get updated automatically and have custom actions on these checkboxes. So clicking this changes what is selected as render device, updates here as well. So there are some bindings going on there. So yes, we'll have obvious look at that first simple stuff, and then as time goes on, we make this more complex, the whole command. Then we'll add more stuff. So more commands that I want to do is, so this is just a one object. We have array linear and these types of commands already in Rhino, but I like to have, for instance, you would specify two points in Rhino space, and you would tell I want 5 objects between these points, and it would exactly be put between those points without having to tell beforehand how many you want to do. So a little bit different approach to the current implementation of, say, array linear or array. And maybe add some settings like randomize location a little bit between those two locations, so you have 5 objects that have a bit offset along the axis, for instance. We'll see. But there are many things you can do, and as always, just keep asking for specific things to work on during these streams. So we have now a working DisplayConduit and a working command, and next time panels, and in the future custom objects and more cool stuff. So thank you for joining, all those who have been following this, and I would say have a nice day. Bye.